Alright, so I have read, byte, and 32 and 32. Reads a sequence of bytes from the current stream and advances the position within the stream by the number of bytes read. So let's see. What are these called? Okay, so it's just a max. Okay, no problem, no problem. So this is what I'm gonna do. We're gonna say int limit equals math dot min sorry. So we want the min of either count or stream bytes dot size or count. Okay. Excellent. So that makes sense. We're gonna read. This is gonna be the max. Can I rename this? Max read bytes. I didn't. Alright, count's fine. Alright, so that's what read is. What about seek? What do I have to implement when I do seek? When overridden sets a position within the current stream. Alright, so offset relative to origin, value of seek origin, and what is seek origin? What are my values? What can it be? Okay, from the beginning, from the current, or from the end. Alright, cool. So, seek. So, if origin equals seek origin dot begin, position just equals offset, else if origin equals seek origin dot current, this would be position plus equals offset, otherwise origin equals seek origin end. I guess it should be position equals stream bytes dot count plus don't know, plus offset. So that means offset should be negative? I think so. And I guess you just want me to return the position. No problem. Okay. That makes sense. I think. So that's seek. So we got read, we got seek. I guess I should read from the actual position, right? Position minus count. Should this be long? Oh, minus position. That makes more sense. So you're getting the minimum of that. and then we're just saying long, oops, long I equals position, I less than limit, or let's just go 0. Okay, it would be position plus offset plus I. Oh, nope. Take out the position here, I think. Alright, so I think in the buffer, yeah, we just get in the offset plus I, which would be 0 to limit. Okay. And then from the stream bytes, it's whatever position we're at plus I. And I guess I should make this as an int. Alright. What about convert dot to int 32? I'll just do the whole thing, why not? Okay. That makes sense. Alright, so that all looks good. I don't know why that's okay. Anyway, I won't worry about it. And then all you gotta do is say position plus equals limit, and then we're good. Alright, what is the set length? Set length, when overridden, sets the length of the current stream. Oh, okay. So that's kind of weird, but I will do it. So if value is greater than, oh, here we go, while value is greater than sorry, I'm just thinking. Alright, so value is greater than stream bytes dot count, or basically length. Then you can just say stream bytes dot add 0. Okay. So that will handle it if value is higher. It'll just 0 pad it. If it's less than length, I'm going to say dot remove at length minus 1. Or stream bytes dot count minus 1. Okay. And otherwise, it doesn't do anything else. Okay, cool. So it just sets the length of the stream. So right. I don't know if I'm doing that one right. What's right? So what does right do? Right when overridden a derived class, writes a sequence of bytes to the current street and advances a position. Okay. That's what I thought. And what about read? Alright, reads a sequence of bytes from the current street and advances. Okay, awesome. Okay, so like read, we will kind of do the same thing here. Alright, limit is count or that. Okay, cool. Actually, there is no limit on this one, so that's okay. So for int I, offset I less than offset plus count I plus plus, and then you can just say I here, but it's not quite that. We just have to do stream that bytes dot add buffer I, and then you just say position plus equals count, and yeah, we don't actually have to do any of that other stuff. Okay, so override, so you don't void. Alright, seek. What does seek do? Seek on the stream does what? Stream seek. What do you return? You returned a new position. Okay, cool. And that's what I'm doing. And what about read? Return value, the total number of bytes read into the buffer. Yes. That's exactly what I am returning. Except you should do limit, not... Alright, limp is the count. Yeah, I don't get why using long and then int32. I don't like it very much, but that's okay. So convert int32. Alright, so I got read. That's how many bytes we read. That's our position, void, but we're setting the length, right. Okay. So I made a custom stream. I don't really know much about streams or anything, so before we tried to do this in a memory stream. So now, instead of a memory stream, I wonder what would happen if we do a custom stream. Custom stream CS equals new custom stream. And we'll just leave it blank like this for now. And then CS, no, BF dot serialize. And it'll say CS, small packet. And stop it there. See what will happen. Wow, it used my custom stream. Awesome. So the position is 145, but there's nothing in my stream bytes. So I wonder why that is. Why did that happen? Alright, so custom streams. Maybe I'm saying this wrong. I think I'm doing this the opposite way. So if I look at here, reads a sequence of bytes from the current stream and advances the position. So when you read from a stream, what do you do? Reads a sequence of bytes from the current stream and advances position by the number of bytes read. And writes the other way, right? Writes a sequence of bytes to the current stream and advances. Okay, so that should be fine. Write int offset plus count I plus plus stream bytes add buffer I. Oh, yep, not quite. Buffer I. Actually, yeah, it's off. Yeah, I. Okay. And position plus equals count. I'm gonna try this out, see what's happening here. So stream bytes is actually getting some love here. Yeah, okay. Oh, stop stepping out of here. Okay. So custom stream serialize. Oh, what's the last thing? Stream byte stop flush. I guess that's the last function I didn't really look over. Clears all buffers for the stream and causes any buffer data to be written to the underlying device. Let's see. I just wonder if this is being run too. Yeah, I thought so. Towards the end, I guess? Yeah, okay. Alright, so I'm going to say position equals 0, and that's about it. So the rest is being done outside of the stream. So the stream's not being the issue. So that is good to know. That was a long detour, but it was good. So now we know that the custom stream, if we look at CS, it's 145, and I bet if I did the same thing with the memory stream, it's also 145. Okay, good to know. So it's good and bad. So it's not about the streams. So this custom stream really isn't doing anything special for me. But here's the good thing. I can now just say custom stream. And what will happen is, don't even need to worry about my special object just yet. Might just comment it out for now. Alright, so here we go. Small packets, has a command and a key, has a binary formatter, and then I just say, hey, use the custom stream I made to serialize a small packet. And I probably don't even need to do that. And then I can serialize and then deserialize. So let's see what happens here. So right now my output object's null, my small packet's that. Serialize it. So if once I serialize it, you can see that this is 145 bytes, which is too big, I think, for just a class with 2 bytes, because you can see that this is a byte and this is a byte. Well, I don't know if you can see that, but if I went here and went here, you can see. How do I see what the type is? Anyway, if I went to the actual class, you can see it's a byte and a byte. Alright, good deal. So I was hoping this would be like a couple bytes big. But it's not just using the standard serialization here in C#. So let's figure it out. So we got BF serialize. And then hopefully if I hit F10 again, the output object is just the exact same small packets with 5 and 1. Awesome. Good deal. So the serialization of deserializing and deserializing worked fine. It's the what I'm not happy about is how it's serializing. So that's why I kind of wanted to mess with these classes. So if I said you were serializable using serialization, and then copy these two things, where the first one is small packet, yeah, so it's pretty minimal what I was trying to do, but even my minimal stuff didn't really work. So if I said info.addValue, if I didn't just said C for command, and I just say command, and info.addValue, K for key, and key. That's 2 bytes. And then on the flip side, so command equals info.get byte C, and key equals get byte K. And then I looked at my custom stream, or if I looked here, oops, I see that I don't have a CTOR. I just need a blank CTOR like that, just so this won't give me an error. Okay, so new small packet, command key, and let's see what happens. So F10 a few times, small packet, 5.1. Okay, binary formatter, that's just a built-in class, no problem. Custom stream, awesome, and right away we can see that the position is 0. F10, It's smaller because I named it to C and K as opposed to like command and key, but you can still see it's still quite big, 137 bytes. And I want to say it's all this overhead. And if I look in here, right here at 89 and 90, we can see that it's is the actual object. And the rest of the stuff is probably like the class name and all of that. So I wonder, CS or console dot whatever, a string test equals BF, not BF, CS dot stream bytes. We can't get it. I mean, I can just by making it public. Public stream bytes. Or how to do that? Encoding dot ASCII dot get string from CS dot stream bytes dot to array. There we go. So I get to see what this is kind of putting out. So there's a lot of stuff here. I'm going to kind of copy this and put it in a notepad. This is the ASCII representation of what it's putting in. Okay, so yep, I got all of this. Example game is the namespace, version 1, culture neutral, public key token. So you see there's a lot of stuff getting put in here. Example game, that small packet. And yeah. There is a lot of data up in here. Where in reality, all I really want is this. And yeah. C# serialize smallest serialization. You can use protocol buffers. What's the fastest serialization mechanism? I'm trying to figure this out. Memory stream, binary formatter, b.serialize, stream to serialize object. Yeah, I'm not too sure about all of this. So let's see, large size, binary, JSON. In computer science and context of data storage and transmission, serialization is the process of converting a data structure or object state into a format that can be stored. Yes. And resurrect it later at some other time. Yes. Serialization is the process of converting the state of an object to a form that can be persisted or transported. Okay. The serialization technique may roughly be divided into two types, human-readable and binary. The .NET framework provides binary formatter class for the binary serialization of, and the XML serialization for human read. Okay. Most sources recommend you use binary formatters to the XML. If we need small size of serial data, I almost never use XML serializer. Okay. Alright, get bytes with binary formatter and get bytes with manual writes. Okay. Alright, yeah, the metadata is it's almost killer. So that's why binary formatter is kind of, What else can I do? Let's look at, before I give up, binary formatter alternative. If you use binary writer instead of serializer, you'll get desired minimal size. So let's see, binary writer. Jeez, yeah, I don't know. I'm thinking, I'm gonna keep looking. Alright, the current issues, backwards compatible, size, and speed. Alright, binary formatter versus manual serialization. Okay, let's see. Public static T, raw deserialize. Alright, how do you serialize? Object anything. Wow. I don't see a very good alternative besides this binary formatter. Binary formatter is pretty nice, I must admit, but the overhead's kind of killer. Especially with some of the calcs I was doing, right? So like, say we had 30 objects on the screen, so we had like 150 bytes per object times 30, so that's already 4K, and then times that by 10, we already have 45K a second. And then, and that's just like one of the packets, like. But imagine if I can do everything in like, I don't know. And that's just a 2-byte thing. So let's say we had some stuff that had actual like density to it. So let's just say that times how many bytes? Like 30, 40 bytes, so 40. It's almost like in a meg, and like I think it's just too much to have a meg per second. So I really want to keep it down from 150 to like or you know what? Let's not do small packet. This my special whatever class is a better representation of like the objects we'll be dealing with. Might be still kind of small, but good enough. Control K U. So there we go. Input object. And let's play this. Okay, and then, oops, I have a stop point there. So that broke. Before it broke, that's 538. So this is 538 bytes, and let's just say I sent that like 10 times a second. So that's one object takes 5 KB, and that's ridiculous. But what else am I missing here? Exception throw. What was the problem? Well, anyway, my custom stream is probably not a good example. We should totally use the memory stream. So we have a byte buffer equals new buffer. 1024 is pretty good. And then we can just put this buffer up in here. And then we can just say cs dot seek 0 seek location origin dot begin. And yeah, that seems good. It's not new buffer, new byte. Alright. So this should still be like 538 or whatever it was. .538, yep. Seek back to the beginning. And I don't know what the error is. I can do the other thing and just say cs.close. And this really shouldn't be cs, it should be ms. And then ms dot equals another new memory stream of buffer. And then, oh, well duh. The problem wasn't with memory stream at all. It was because I was trying to do small packet. So let's see. So yeah, the problem was totally not me. It was that I'm not making it my special class. That's the problem. So this should totally work, right? F10, F10, F10. Where did I go wrong? Input object. Alright, I'll still do memory stream. Zero, seek origin, begin. Should be memory stream. This is not a thing anymore. And F5. F10, F10, seek to 0, read. Something went wrong again. Maybe it has something to do with this. I can now not worry about doing any of this. It still should be pretty close. .556, slightly bigger. And there we go. We get this and the numbers. Awesome. Okay. So this probably still works with custom reader, I'm guessing. So if I undo this, undo all of this. Hit play. Yeah, still seems to be working with my custom streamer. And then F10. And this is but I see Notepad Yep, you got a generic list in there. If it wasn't for all this other data, like I can even take the string here, the readable data. Good job as an official, man. That's great. I'm glad you're learning on the Raspberry Pi too, man. Okay, so all in all the serialization talk just made me realize that I should totally stick with making my own serialization. But the stream stuff isn't too bad. So, alright, so what? So if I wanted to serialize this my own way and deserialize this my own way, how would I do it? So if I wanted to make my own serialization, so stop this. This will be my last. I think I want a byte array or byte list. Why not? Byte array sounds better. Alright, public static byte serialize. Okay, and so how we're going to serialize this will be not too shabby. We will get the size of name. Alright, or the size of special class. So here we go. List byte serialization equals new list. Okay, not bad. This will be my manual serialization. So the first thing I want to do is just say how many bytes this object is going to be. So we don't know that yet, so that'll be towards the end. So serialization add. Well, before I do that, let's do this. We will say, yeah, never mind. Let's just say bytes serialization dot add range bit converter dot 2 bytes or get bytes of first things first string. Nope, name. Actually, strings are a little different. Encoding dot ASCII dot get bytes name. That's how I'm going to handle strings. And this can't be, it's going to have to be like this, virtual. Okay. So far that makes sense. Serialization add range. So we got the name, bit converter dot get bytes x, y, and z. We're going to get the instance ID. And Serialization dot add range numbers dot get bytes. Okay. My manual serialization. So, yep. We're getting the name, XYZ, instance ID, and now numbers needs to get its own kind of serialization. So I am going to put this in the util class, which will be, yes, public static byte get bytes. Actually, better yet, let's make a serialization kind of a class. Manual serialization. This is going to be a public static class. Public static class. Manual, yeah, that's a lowercase s. So whatever I was about to do here, get bytes, this list of int, and we can just say numbers. And this should be pretty easy. We can make a list. So we have numbers, right? Or actually, no, this is going to be serialize. Serialize. List int. Serialization equals new list of int. No, a byte. I'm sorry. This is going to be a byte array at the end of the day. Byte, byte. So that makes sense. Serialization dot add, or for each. Yeah, that's what we need. For each int I. For each int I in numbers. Serialization dot add range bit converter to int 32. Nope, sorry. Bit converter get bytes of the int, which is going to be I. And then at the end here, we're going to say serialization dot add, insert. Insert. Serialization dot count at insert range 0 bit converter dot get bytes serialization dot count return serialization dot to array. And there we go. That's how you serialize the list. And let's go ahead and deserialize this list. Deserialize. What's up, Bamboy? Hope your friend was okay, or getting better. Alright, deserialized. This is should give me a list of int. But you'll have a byte of numbers. Yeesh. Sorry to hear that, man. Alright. Alright, a list of bytes is going to be deserialization equals new list of bytes, and I think I'll just put data up in here. Okay, so for this portion of it, int size or count is going to equal oh yeah, didn't we have a byte? It's very helpful. A byte queue. Yeah, this would be awesome if we can have it. So instead of a list byte, let's have a byte queue. Byte queue. And this is how I'm going to roll with it. I'm going to say count equals deserialization dot dq, and I can say 4. And this is what I can do. Bit converter dot to int32 deserialization. Oh, 0. Cool. For int I equals 0, I less than count I plus plus, and we can make a new list, right? A list of int numbers equals new list. So that's gonna be here at the top, and then we can just say numbers dot add, and we can say this bit converter again. Yep. So what is this serialization thing? So this is, so what I've done for like the last hour and a half was I was using something called bit formatter, and I'm not sure if I have it. Yeah, so bit formatter. So basically, if we take a class like my special class, and it has you know, string name, float, and all of that, if you make it serializable, and you don't have to have this this whole other thing is something I'm working on by itself. So everything above this is the class, right? So you make a class, you set all like the variables, and then you can say, hey, bit formatter, can you serialize my object into the stream? So the stream could be like a memory stream, it could be a network stream, it could be any kind of stream. And so we made a custom stream where basically it just adds all the bytes into a list. And then so you can serialize that into the stream, and then that stream, that list, and then from that list you can actually create the object again by doing deserialize. So serialization kind of makes your object into the stream you can send around. So yes. But my big problem with the bit formatter is just for this one object, this took 558, or no, 562 bytes, and that is just a little too big for what I needed. So, because I'm going to be running this every like 100 milliseconds, that's one object, 562. That alone for one object, 562 times, we'll say like 10 times a second. This would be 5K a second for one object. So say we had like 30 objects on the screen. It's 168K. Say we had like that times 4. 674K. So it's pretty heavy. So I don't want to use this bit formatter. So I'm making my own serialization. So that's why I'm working on this like manual serialization thing. Kind of what I've been doing, but now it's in a format that I know of. So list.numbers, deserialize. Okay. So that's the list. Serialization. I think this is all okay. And then just return numbers. Alright, so I got the list deserialized, so back to my special class. We should be able to say numbers dot deserialize or serialize. Yeah. Why didn't it deserialize show up? I don't know. Where is... Oh yeah, so... Yeah, I'm not quite sure how I want to handle this. But this looks fine. And then serialization dot add range bit dot converter dot get bytes of this next thing, which is going to be serialization dot size dot count. There we go. And then we can return serialize.toArray. Nope, sorry, serialization dot toArray. Alright. I don't mind that too bad. And I meant to say insert range 0 bit converter. Yes. Okay. So my special class, my serialization looks like this. Serialize. So hopefully if I go to example game main, I say show me the serialization of input object. This is the manual serialization of it. So I'm going to go here, hit play. It's crazy. When I don't build it for a while, it takes forever. It's okay. Instead of 550, this is now only 60 something bytes, or 70 bytes. So that is pretty good factor of size. So 58 divided by 69 made like 8 times smaller, which is great. Okay, so that's great. Now how do I deserialize this? So here's our serialization. Now I'm going to deserialize it. So public static public static my special class. So I'm going to get a my special class. And what else? What else? Deserialize. I'm sorry. My brain kind of broke. Deserialize. And then we're gonna need some bytes. Data. Okay, and I'm gonna use this byte queue that I made. It's pretty cool. And this is just gonna be bytes, or what did I call the other one on manual serialization? Or deserialization, sure. Deserialization equals new byte queue data. Okay. So now we can say deserialization. You can say int size equals deserialization of what? Int size deserialization.dq 4. And almost just like this, right? So that looks good. So we got the size of the packet. Okay. Sorry, just thinking. Sorry. My brain is broke. Alright. But we're almost there. Bit converter dot get bytes of that. Okay, so this is the size of the whole packet. This is going to be the size of name, or we'll just call it name size, equals bit converter dot to int 32. Yep, basically this. Right, so you got name size, and then we're gonna say string. Here we go. We're gonna make a new special class, right? So my special class, new my special, or just new instance equals new my special class, right? And then we're gonna say name equals, or new instance dot name equals deserialization. Nope. Encoding dot ASCII dot get string from bytes. Deserialization dot DQ name size. There we go. So now we got the string, new instance dot, looks like I'm doing x next, equals bit converter dot to shoot, what is it? Is it float? Yeah. To single. Deserialization dot DQ 4. Yeah, 0. Is that what you want? Yep. X, Y, and Z. And 32. And let's see. This next one's going to be a little bit different. Instance dot numbers equals I don't even know. Manual serialization dot deserialize. I wonder if I could do like data. Or you know what? Deserialization dot to array. Nice. I think that should work. And then return new instance. Alright, so if I go to my example game, I don't do any of this custom stream stuff for now. And all I do is we have serialization, and then I just say my special class output object equals my special class dot deserialize serialization. And then I just kind of see if that works. So that's my serialization, 73 bytes. And let's see what happens here. Okay. So I'm going to stop that here. F10, F11. Let's see what happens. So that's special class. Size is 69. I already think that's wrong. Or that might be right. Name size is 9. Name. New instance of name is test case. Excellent. Oh, I see I have Z twice here. That's not what I wanted to do. Instance ID. That should be all okay anyway. So 10. So okay, that all looks pretty good actually. So if I look at my new instance, yes, okay, that all looks great. So how's our deserialization looking? 40. And we have 36 there. Okay, so let's jump in here. So we're going to have this new number, deserialization, count 36. Okay. No problem. Oh, yep, I got what you're saying. This divided by 4. Or this divided by 4. Alright, so new instance. Even have numbers. Awesome. Good deal. Name 22. Alright, cool. So, manual serialization, example game. Control F11. F10. Output object. So they look about the same, right? 22 test case, 9-1. 22 test case. Okay, great. So I've serialized an object. And that's kind of what I've been doing, just not formally like this. So manual serialization. I might just call it serialization. Yeah, let's do that. So wherever I have manual serialization, let's just name you serialization, if you don't mind. Serialization. Misspelled it, but yeah. Serialization. Okay. I'm going to put 2 classes in here. Public class deserialization, public static class deserialization. And list int. Let's see. List int. Okay. Oh. Deserialization. List int. Okay. Serialize, deserialize. Awesome. I might want to work on 1 or 2 more, namely game objects. So let's look at game objects. So here's what I'm going to do. I'm going to move the serialization let's move you over to the Unity engine namespace. Serialization is going to happen here. I get to delete it from here. What else? What else am I going to get rid of? I'm going to get rid of this custom stream. That's okay, that's okay. My special class. I don't know yet. Object map. Yeah, I was thinking about using that, but I think I don't know yet. Player script. I might be done with player script, maybe not. Server control. I need server control. I need you. I need you. Small packet can go away. Unity scene reader is good. And util is good too. Alright. So this is probably my game object and stuff. But anyway, I won't get there yet. Okay, so I think I'll start it here. And this will be internal. This one will be byte. Serialize. Return new byte 0. Let's make it virtual. Okay. Game object is what I want to work on. So game object, go down here. This is just static. How about I just override? Serialize. We're going to need a list of components. Let's see, where's my Unity scene? Here we go. Okay, so I'm going to make a list of byte. Serialization equals new list of byte. Alright, serialization dot add. Object. Alright, what about prefab? Alright. Alright, object hide flags. Don't know yet. That's why it's going to be commented out, commented out, commented out. So that's okay. So we're done with these. And I guess serialized version too. Serialized version. Serialization that add range, list of components. So not what I want right here. Where is my serialization? Here. Okay. For serialization, I have that. I also need this.list component. Alright, so for obj and objects, and we better just make you object. For each object in there, this is what we're going to do. obj.serialize. Okay, cool. And at the beginning, we're going to get the count. Okay. Okay, I'll look at components. What is it? A list of components? Yes. So, okay. No problem. But let's go ahead and serialization. Let's go ahead and make this instead of a list of objects. I thought it was a good idea, but it's probably not. This components, 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 and everything else seems great. Okay. So components.serialize. Okay, so that works. Got that. mlayer serialization dot add range bit converter dot get bytes layer is an int, right? Yep. Serialization.add range, encoder encoding .ascii .get bytes, name .length, this whole thing, bit converters .get bytes. Okay, so we got the name, okay, bytes, icon, layer, flags, is active. Alright. Static, editor, flags, and finally is, or enabled, active self. Okay, cool. I think this is looking pretty good. Alright, so this is the serialization. And of course we can do the deserialization. So internal game object, internal game object, deserialize, byte, data. That seems good. Alright, so we got deserialize. It's going to be very similar to serialize. So if I look at my special class, something like this. We'll just call it obj equals new game object. Deserialization. Doesn't have to be that complicated or confusing. Alright, so byte queue is pretty good. So we're going to take it from game networking. And I'm going to put it in Unity Engine. Unity Engine, byte queue. This is more of an internal class, it's not really public. So, yeah. Alright, byte queue, that's great, deserialization. Yep, you get the size first, which is great. The name size. I'm starting to see components. It's going to equal, it's not components, it's object dot components equals I think we'll do deserialization dot, we should make another one in here under serialization. Public static list component list component this byte data so totally make a new list of components equal new list of component, and at the end of the day we're going to return components, right? Somewhere in between we are definitely going to do byte queue deserialization equals new byte queue of data. Yes, the count is going to equal to bit this. Then we just say for int I equals 0, or actually while I is less than int I is less than while count is greater than 0. Um, components.add So we gotta know the int component size equals okay, before we do that, we'll just say while count's greater than 0, components.add component.deserialize deserialization.toArray. Deserialize. Alright, so we're going to get component now. So we did, or we're kind of working on object right now. And we'll say deserialize list of components. Data. Component size is basically this. It would be nice if we could pass in the byte data, right?